So this week we're going to be looking at how to graph quadratics in vertex form, in standard form, and in factored form. Sorry. First, we're going to look at vertex form. Vertex form is probably the easiest form to graph, but actually, before we even get into that, we'll just talk about a little bit about some general features of all quadratics. So you know a quadratic has this U shape, and it could open upward or downward, so it could be a regular U or an upside down U. And this point, the extreme point here, either on the bottom or the top, I think you guys know that's called the vertex of the parabola, and that's a key feature whenever you're graphing one, because that's the bottommost or topmost point on the parabola. Going along with that, a vertical line passing through the vertex. If you look at one side of the parabola versus the other side, across this line, they're a mirror image of each other. This imaginary line is known as the axis of symmetry, because that is the line over which you can reflect the parabola and it'll line up on top of itself. Or if you have points over here, you can reflect them over that line to get them on the other side. We've got a vertex and axis of symmetry. Those are the key features of a parabola. They also have, x-intercepts, also known as zeros or roots. Those are important, and y-intercepts can also be important for a parabola as well. And x-intercepts you find by plugging in 0 for y. Y-intercepts you find by plugging in 0 for x. Now, vertex form looks like this. And this format was the end result we got when we completed the square, which all of you were so thrilled about. But this is one reason why completing the square is useful, is because vertex form of a parabola is very easy to graph with. Because when we have vertex form, it tells us where the vertex is. This value and this value tell you what the vertex is, h, comma, k. The ordered pair hk is the vertex of your parabola. So if you have x minus 2 squared plus 3, the vertex is at the point 2, comma 3. And since the axis of symmetry passes through the vertex, then the axis of symmetry will be the vertical line. A vertical line has equation x equals a number, and it's just the x coordinate of that vertex, x equals h. And then the value of a, if a is positive, you'll get an upward opening parabola like that. If a is negative, you'll get a downward opening parabola like that. If I want you to graph a parabola, I want 5 points. So for a graph, I want 5 points. And I do not want you to just plug in x equals 0, 1, 2, 3, 4, 5, 1, 2, 3, 4. I want those 5 points to be 1 point to be the vertex, 2 points to the right of the vertex, and then mirror those 2 points to get 2 points to the left of the vertex. So 5 points, 2 to the right of the vertex, 2 to the left. Figure out the vertex, graph 2 points on one side, reflect them over to get 2 points on the other side. Work through this example of how to graph a quadratic in vertex form. We're given f of x equals 1/2 times x minus 1 squared minus 2. And I want to find the vertex, axis of symmetry, zeros, and graph. This is vertex form, so finding the vertex is really easy. We can just read it off the equation. X minus h, so h is 1, and it's plus k, so k is -2, so our vertex is going to be at 1, -2. So we can start our graph with that. 1, -2. Axis of symmetry then, which I will abbreviate axis of symmetry, is just a vertical line passing through the vertex, and a vertical line is x equals 1. So our axis of symmetry is at x equals 1. If you wanted to graph that, you can make a dashed line. You don't need to graph it if you don't want to. And then we want to find the zeros. Now remember, in vertex form, we know how to find the zeros. Just plug in 0 for f of x. So to find the zeros, we go 0 equals 1/2 x minus 1 squared minus 2. We did this a lot when we were completing the square. Add 2 to both sides. So we get 2 is 1/2 times x minus 1 squared. Get rid of the half. We can multiply both sides by 2. That gets us 4 equals x minus 1 squared. Square root both sides. We get plus or minus 2 equals x minus 1. Add 1 to both sides. We get x equals 1 plus or minus 2. So our zeros are 1 minus 2 is negative 1. 1 plus 2 is 3. So our zeros are at negative 1 and 3. We can graph those. And then we just need one more point on each side of the vertex to finish our graph. And we can go ahead and plug in whatever we want. We can plug in 2. I'll plug in 2. So f of 2 is going to be 1/2 times 2 minus 1 squared minus 2. 2 minus 1 is 1. Squared is 1. Times 1/2 is 1/2. Minus 2 is negative 1.5, negative 1.5. So we have the point 2, negative 1.5. That's right here. And we know that right here, down the middle, is our axis of symmetry. So if we reflect that to the other side, we go 1 unit here to get to here, so we'll go 1 more unit here. So the point 0, negative 1.5 is also on the graph, and then just connect the dots. And we've got the graph of our parabola. Just to do another example, say we wanted to graph negative 2 times x plus 1 squared plus 4. Just looking at our equation, we can see that our vertex is going to be at negative 1, 4. So you can graph that, negative 1, 1, 2, 3, 4. And then it doesn't say to find the zeros or anything particular. So we can just plug in 2 more points. Let's see what happens when we get g of 0. That's just to the right of there, so that's a good value to plug in. Negative 2 times 0 plus 1 squared plus 4. 0 plus 1 is 1, squared is 1, times negative 2 is negative 2, plus 4 is 2. So that gives us the point 0, 2, right there. And we can then plug in 1. So we have negative 2 times 1 plus 1 squared plus 4. 1 plus 1 is 2, squared is 4, times negative 2 is negative 8, plus 4 is negative 4. So that gives us the point 1, 1, 2, 3, 1, negative 4. And once again, our axis of symmetry, just this vertical line that passes through the vertex. So we can mirror those 2 points over. This is one spot to the right of the axis of symmetry. So if we go one spot to the left, we have the same y value. Here we're 2 spots to the right of the axis of symmetry. So if we go 2 spots to the left, we'll have the same y value. That's over here at negative 3, 4. Connect the dots. And we've got our parabola. Also go the other direction, looking at a graph, or if you're given points for the vertex and another point, how do we write the equation? Now we know that our formula for vertex form is x minus h, or a times x minus h squared plus k. We know h and k are the vertex of the parabola, so for this particular graph, our vertex is at 2, negative 3, so that's going to be x minus 2 squared minus 3. And then we're also given a point that's on the graph, and that enables us to plug that in to figure out what a is to finish off our equation. So our point on the graph is 3, 1, and that's x comma y, so we can plug those in to figure out what a is, much like we did when we were writing equations from factored form. Plug those in for x and y to solve for a. Add 3 to both sides. gets us 4 equals 3 minus 2 is 1. Squared is 1. Oh, that's convenient. So 4 equals 1a. So then we can write our final equation. F of x equals 4 times x minus 2 squared minus 3. So that's how you can write an equation in vertex form if you're given a graph, or if you're just told the vertex is this point and this other point is on the graph. Now, how can we figure out how to graph or deal with something from factored form? Say we want to graph this guy right here, 3 times x plus 2 times x minus 6. Now, we've got 2 points that we know right off the bat. We know our zeros. We know our one zero is x equals negative 2. And another 0 is x equals 6. 1, 2, 3, 4, 5, 6. But how can we figure out the rest of the graph from there? Most importantly, how can we figure out the vertex? Now, the thing we know about parabolas is that they're symmetric, okay? Which means that these 2 points, since they have the same y value, they're mirror images of each other over the axis of symmetry. So if we're at 6 and negative 2, that's 1, 2, 3, 4, 5, 6, 7, 8 units apart. That means their axis of symmetry must be halfway between those two, which is 4 units. 1, 2, 3, 4. So our axis of symmetry is right here at x equals 2. The axis of symmetry is halfway between the 2 zeros. In this case, it's at x equals 2. It's always halfway between the zeros. It's not always x equals 2. If our axis of symmetry is at x equals 2, well, then we know our vertex must be at whatever we get when we plug in 2, which is 3 times 2 plus 2 times 2 minus 6. 2 plus 2 is 4. 2 minus 6 is negative 4. 4 times negative 4 is negative 16 times 3 is negative 48. Our vertex is at negative 48. Then we're going to graph that point. Then we just need one more point, and it's mirror image. 0 is easy to work with, so I'll plug in 0. So plug in 0, that gives us 3 times 2 times negative 6, which is 6 times negative 6. So at 0, we're at negative 36. I cheated ahead of time and got my graph set up, but we need to go down to negative 48, so it doesn't make sense to scale by ones. I chose to go by 5, so it's negative 5, negative 10, negative 20, negative 30, negative 40, negative 50. So those are going by tens. I guess those are hard to see on the screen, but I'm going by 5s with each tick mark, so it's 10 every 2 marks. My x-axis, I'm just going by ones. 1, 2, 3, 4, 5, etc. So I've got the point to negative 48, which is here, down almost to 50. And then 0, negative 36, which is going to be just past 35. And then we can reflect that over. That's 2 units from the axis of symmetry. So we go 2 units in the other direction, get the point 4, negative 36, and then we can draw our curve. So the key thing to remember in factored form is that the axis of symmetry, and therefore the vertex, the x value is halfway between the 2 zeros. So you can use that to figure out where the vertex of your parabola will be, and then graph it from there.